Hello, my name is Benjamin Nicholson, and I'm an air resources engineer with the Climate Investments branch of the California Air Resources Board, and I work on California's Healthy Soils program. The Healthy Soils program is administered by the California Department of Food and Agriculture, but CARB is responsible for the accounting the benefits achieved by the program. Today, I'm going to talk about how the compost application practice was developed, quantified, and applied in the Healthy Soils program. While most other practices in the Healthy Soils use Natural Resource Conservation Service practice standards and Comet Planner greenhouse gas benefit calculations, compost application is a little different. First, a brief primer on how the Healthy Soils program is funded. Money raised by the California Cap and Trade Program auctions are put in the Greenhouse Gas Reduction Fund. $6.3 billion have been implemented since its inception. The fund is used to support programs and state agencies whose projects further reduce greenhouse gas emissions, as well as providing quantifiable benefits to the local communities. These include programs associated with growing food and managing food waste. The Climate Investments branch of the Sustainable Transportation and Communities Division manages these investments, determines how to quantify the benefits of the projects, and reports these benefits annually. So the Healthy Soils program is one of many funded from the GGRF. Each year, the legislature decides how that money is to be apportioned to different programs. Programs not only include Healthy Soils and other agricultural programs, but also forest health programs, transportation programs, and building efficiency programs. The Healthy Soils program is made up of 25 practices developed by the NRCS and 2 developed by CDFA. This spring, CDFA selected 319 projects for the Healthy Soils incentive funding. The Healthy Soils program has been allocated over $40 million and created a greenhouse gas benefit of roughly 127,000 metric tons of carbon dioxide equivalent. Here is a pie chart of the number of practices in projects selected during the 2020 Healthy Soils solicitation round. Most projects propose to use multiple complementary practices, so the total number of practices shown add up to more than 319. Of the 319 projects selected, 80% of them include compost application as a practice in that project. It is far and away the most popular practice in the Healthy Soils program. We suspect this is the case because of the nutrients in the compost that are directly used by crops to increase productivity. While other practices do have on-farm benefits, such as improved water holding capacity, reduced soil erosion, and increased pollinator presence, none of them affect the farmer's bottom line as directly as free compost. NRCS conservation management practices have conservation practice standards that describe how practices should be implemented. NRCS does have a conservation practice standard for nutrient management, which includes compost application. However, CDFA did not want to require farmers to create a nutrient management plan as part of the application process. CDFA wanted to reduce the hurdles required for farmers to apply. While a nutrient management plan does earn extra points in the Healthy Soils application process, it is not a necessary step. Instead, the predetermined application rate for compost will limit the environmental impacts of compost application without a nutrient management plan. CDFA also made clear which areas are ineligible for compost application, including seasonal wetlands, serpentine soil types, conservation lands, lands dominated by native plants, and watersheds already impacted by nitrogen or phosphorus. Like all practices in the Healthy Soils program, the compost application practice needs to be applied on a parcel where the practice has not been implemented before and be applied each year of the 3-year project life. The farmer is paid $50 per wet ton of compost based on an analysis of compost prices in California. The compost can either be purchased from a certified compost facility or produced on-farm. On-farm compost must use on-farm material only in either a static aerated pile or windrow system. Here are the application rates for the CDFA compost application practice. They are based on calculations of the amount of plant available nitrogen in the compost. Given the difficulty in determining a single rate to hundreds of crop types, the agricultural systems were divided into annual crops, orchards and vineyards, and pasture lands, grasslands, and rangelands. Both high nitrogen and low nitrogen composts can be applied to crops. A carbon to nitrogen ratio of 11 defines the difference between high and low nitrogen compost, based on an analysis of compost in California. Only low nitrogen compost can be applied to pastures and rangelands in the program to limit the risk of impact on plant diversity. The effects of compost application on grasslands continue to be studied. These compost application rates are low, less than 1/4 of an inch thick. They need to be low to keep environmental impacts low. However, even at these rates, farmers have noticed improvements. For instance, pasture land with compost application have stayed green longer into the spring than adjacent land that did not receive compost. Farmers can choose to add compost at a higher rate than the rate shown here, but the Healthy Soils program will only pay for the portion of compost applied at these rates. Programs funded by the California Greenhouse Gas Reduction Fund must account for greenhouse gas reductions and other benefits in an annual report to the state legislature in the spring. CARB is responsible for both determining the quantification methodologies used to calculate the benefits and for reporting the quantified benefits to the legislature. CARB uses biogeochemical models to quantify the emissions and sequestrations in the Healthy Soils program. Biogeochemical models require information about land use, the soil, the climate, the crops, and the land management to determine emissions and soil carbon sequestration. For the Healthy Soils practices that have been developed by NRCS, the greenhouse gas benefit is calculated using a model called DayCent. NRCS partnered with Colorado State University to compile the DayCent results in a tool called Comet Planner. For the Healthy Soils practices that have been developed by the CDFA, which are compost application and whole orchard recycling, the greenhouse gas benefit is calculated using the denitrification decomposition model, or DNDC. DNDC was developed at the University of New Hampshire, and CARB uses it for agricultural modeling. The research division at CARB modeled compost application for each county in California. The DNDC model simulates decomposition, nitrification, denitrification, fermentation, and methanogenesis, tracking the movement of carbon and nitrogen through the 4 different carbon pools: plant residue, microbial biomass, active humus, and passive humus. Daily meteorological data were derived from weather data produced by the DayMet model from the square kilometer cell that was closest to the area-weighted geographical center of croplands in each county. Soil properties were area averaged from the Soil Survey Geographic Database. 53 crops were area averaged from the National Agricultural Statistics Service and grouped into annual, perennial, irrigated pastureland, and unirrigated rangeland. Farming management data, including planting and harvest dates, tillage, fertilization, irrigation, and residue management, were developed for the crops largely from open literature, surveys, as well as personal communications with researchers, growers, and University of California cooperative extension staff. 4 irrigation methods, flooding, sprinkler irrigation, surface drip, and subsurface drip, for each of the 53 crops modeled were taken from the California Department of Water Resources statewide irrigation methods survey. An assumption of 1 head per acre was assumed for the grazing scenarios. The scenarios by crop and irrigation method in each county were modeled for 3 years, from 1998 to 2000, with the year 2000 emissions selected as results for alignment with the modeling used in the Comet modeling. Crop residue carbon was excluded from soil sequestered carbon calculations because of its rapid breakdown to carbon dioxide. When the individual results by crop and irrigation method in each county were weight averaged, there are ultimately 6 compost application scenarios: high and low nitrogen compost application to annual crops, high and low nitrogen compost application to orchards and vineyards, compost application to grazed grasslands, and compost applications to grazed irrigated pasture. Let's look at the results for Fresno County. The benefit from sequestered carbon is roughly proportional to the amount of compost applied to the soil, about 0.6 metric tons of CO2 per ton of wet carbon applied. Of wet compost applied. Because there is no reduction in fertilizer application, the additional nitrogen in the compost creates a nitrous oxide disbenefit. The nitrous oxide disbenefit is, on a per ton of compost basis, higher for high nitrogen compost than for low nitrogen compost. Changes in methane emissions are small. While the Greenhouse Gas Reduction Fund does not require an optimization of greenhouse gas costs, it is an interesting statistic for people. The cost of the greenhouse gas savings for the compost application practices is in the high $70s range for low nitrogen compost and in the low $90s range for high nitrogen compost on account of the nitrous oxide disbenefit. The average Healthy Soils project has a cost of about $173 per metric ton of CO2 equivalent, and the programs in the Greenhouse Gas Reduction Fund have costs ranging from $9 per ton to several $1,000s per ton. In the first year of the Healthy Soils program, the greenhouse gas benefit for compost application had to be calculated separately from Comet Planner. Because it is such a popular practice, most applicants had to use two calculators for their single application of their projects. Recently, in partnership with NRCS and under a CDFA contract, Colorado State has combined the NRCS and CDFA practices into a single working website tool that Healthy Soils applicants use to apply for funds. The Comet Planner for the CDFA Healthy Soils program has been edited to include not only CDFA compost application practice and whole orchard recycling practice, but also the specific NRCS practices that CDFA selected to be part of the Healthy Soils program. All other practices are excluded to avoid confusion. This version of Comet Planner also includes a payment scenario so that the website calculates both the greenhouse gas benefit and the estimated payment the farmer will receive for implementing the practices. Let's look at the difference between the National Comet Planner website and the Comet Planner for the CDFA Healthy Soils program. In the National Comet Planner, practices are grouped by practice management class: cropland management, grazing lands, woody plantings, cropland to herbaceous cover, and restoration of disturbed lands. In the Healthy Soils Comet Planner, there are fewer practices, so they can be grouped by agricultural system: cropland, orchard or vineyard, and grazing land. So if you are implementing multiple practices, you can select them all in step 3, instead of repeating steps 2 and 3 in the National Comet Planner. The risk of accidentally choosing an incorrect practice for your agricultural system is also eliminated. While the Healthy Soils program is at what I'd call a stable equilibrium, we continue to look for ways to improve the program. CDFA is beginning a review of new proposed practices, many of which are other organic amendments to be applied to soil. CDFA has also conducted stakeholder workshops and created a draft framework to encourage private organizations to fund Healthy Soils practices outside of the Healthy Soils program. NRCS is developing a conservation practice standard for compost application that can be applied nationally. Outside of the agricultural sphere, the state of California is increasing its efforts to divert organic waste away from landfills. Composting this waste will dramatically increase the amount of compost available in California. In general, California is increasingly incorporating natural and working lands planning in its efforts to become both carbon neutral and more resilient to the effects of climate change. Due to the effects of COVID on state revenues, allocations of greenhouse gas reduction funds to programs like Healthy Soils have not yet occurred this fiscal year. However, due to the popularity of the program, we anticipate that the Healthy Soils program and compost application will return to improve the soils of California. You can learn more about the Healthy Soils program at the CDFA's Healthy Soils program website. Try out Comet Planner for the CDFA Healthy Soils program at its website, and learn more about the Greenhouse Gas Reduction Fund at CARB's California Climate Investments website. My email is also posted if you have any follow-up questions. Thank you for your attention.